Okay, welcome to the second half of the number 8. Uh, I'm going to do question D, E, and F. Please take a look before on question A, B, and C. Notice those absolute values are all by itself. So before you split them into a negative and a positive equation to get rid of the absolute value bar, you have to get the absolute value by itself. So if you look at question D, there is a negative 9 that is physically attached to the absolute value that you have to get rid of. Okay, so that is the reason why you would have to add 9 to both sides first. This now gets you absolute value 5x plus 2, bring down the bar, okay, greater than or equal to 18 plus 9 is 27. Okay. And then now, because the absolute values by bars are by itself, now you can split it. So the positive version would be your 5x plus 2 is greater than or equal to 27. Okay, that's the first equation. The second equation is the same way, but this time it is a negative 27. And now the absolute value also switches because it's negative. Okay, but the process of solving it is the same. So we're going to subtract 2 to both sides. This cancels, leaving you here with a 5x. This becomes a negative 29. Bring down that bar here. Okay. All right, now we divide both sides by 5. Divide both sides by 5. You get x is less than or equal to negative 29 over 5. Okay. And then here, same process, right? The algebra is the same. Subtract 2 to both sides. This is now going to cancel, leaving you with just a 5x is greater than or equal to 25. Then divide by 5 to both sides. This does cancel, leaving you with just an x is greater than or equal to 5. Okay, this allows you now to graph it. Okay, so if you use your calculator, negative 29 divided by 5, this on the graph, okay, is about x is greater than or equal to a number about negative 5.8. Okay, so if you want to graph it, right, here's the number, I think, what, negative 6, negative 5, let's do 0, and here's 5. The reason why is because you would want it somewhere right here to represent the negative 29 over 5. Okay, then this is where the 5 is. Okay, x is less than or equal to that, so that is to the left because that is less than, and x is greater than 5, so that's to the right. Okay, so that's how it would look like. All right. Okay, so that is what you would have to do. Okay, so let's look at question E now. Okay, is the absolute value by itself? No. So let's deal with that first. Okay, let's first add 3 to both sides. This does cancel, leaving you with the absolute value 3x plus 7. Bring down the absolute value bar. 8 plus 3 is 11. Bring down the absolute value, the inequality symbol. Okay, please understand that it becomes the negative and the positive. The positive version is just 3x plus 7 less than 11. Then the negative version is 3x plus 7. The symbol changes to a greater than, negative, okay, 11. All right. So now we can solve like normal. Let's subtract 7 to both sides. This does cancel. Plus 7 and minus 7 does cancel. Now you get here 3x greater than negative 18. Let's divide both sides here by 3. This cancels. 3 over 3 does become the number 1, so it just becomes x is greater than negative 9. Let's do this problem here to the right. Let's subtract 7 to both sides. You get, this does cancel. Right? And now you have 3x less than 4. Okay. Let's divide 3 to both sides. This cancels. X is less than 4 over 3. Okay, if you want to graph this, 4 over 3 is about, like, it's the same thing as about being less than 1.33 repeating, of course. Okay, so here's the number line. Here's the negative 9. Here's the 0. Here's 1. And no, I should, hold on. Let me make this 0. Let me make this 1. Let me make this 2. Okay, because 1.3 is between 1 and 2. That's why. Okay, so it's open for the negative 9. It's open for the 4.3 somewhere here. So x is greater than negative 9. So that goes to the right. And then x is less than 4.3. So it goes to the left. Oh, so this is an and problem. Okay. Look, it's connected. Right? Let's see if it makes sense. Let's double check. Okay. Right? Oh, yes, because do you see how all the and ones have this symbol? Right? It has the less than or equal to symbol. So this is a less than or equal to symbol. That's why it's also an and. Right? So f, do you see how it also has that symbol? That's also going to be an and one. Okay? All right. Okay. So let's do f. Make sure the absolute value is by itself. Subtract 11 on both sides. Here's the line. This does cancel. The absolute value here is absolute value 4 plus x. Make sure you write this step. Bring down the inequality symbol. 8 minus 11 is negative 19. Okay? All right? So now it becomes, it's two equations, the negative and the positive. The positive version would just be 4 plus x is less than negative 19. And then the negative version, no. Ooh, haha. This is not possible. Here, this is a, let me write, a no solution. And why is it a no solution? And from before, we noticed that the absolute value represents distance. There is no way that the absolute value can have a negative distance. Okay, right here it says it's less than negative 19. This is impossible. I want you to think about this. Whatever number you put in here, right, for x, right, like let's say you put in a, let's say a 5, right, it becomes a 9. That's impossible for it to be less than 19. Let's say you put in a negative 20. It becomes it becomes like negative 16, but it still becomes a positive number, right? So notice that the left side will always be a positive, right? Okay, so it's going to be impossible for the left side to ever be less than negative 9. It would be impossible. Okay, so no solution. The absolute value here represents a distance. There's no way that the absolute value can have a negative, oh, I forgot one more word here, a negative distance. Okay, of negative 19 for this case. Okay, all right, but there you go. So everything worked. The only issue is that F is a no solution. A lot of you try to get F as having a solution, but there's no way you can do it. Okay? All right, so there you go. These are all your solutions.